Okay, let's look at some triangle properties, and we're going to focus on the exterior angle theorem, and we're going to review the triangle sum. We'll use things like linear pairs and things like that, but really this particular section opens Unit 5 by looking at triangle properties. The first thing I want to do is remind you how to prove the triangle sum. So let's just take two parallel lines. Remember they're parallel because I've labeled them parallel. You can draw any triangle you want. And let's call this angle 1, angle 2, angle 3, angle 4, and angle 5. Okay? And this is a very small proof, but we know that the angle addition postulate says that we know we take angle 4 plus angle 3 plus angle 5, and we know that's 180 degrees because those three angles make a straight line. They're like a linear triple, right? Linear triple. I like that word even though I think it's probably made up, right? We know linear pair, but linear triple should be a real vocab word. And then what else do we know? Well, we know that if these two lines are parallel, then angle 1 and angle 5 are actually, angle 1 and angle 4 are alternate interiors. And we know alternate interiors are congruent since the lines are parallel. So we can say that angle 1 is congruent to angle 4. 5 and 2 are also alternate interiors, and they are congruent because the lines are parallel. But if 1 is congruent to 4, and we can make a substitution, we can take where angle 4 used to be, and we can say, oh, we can replace that by angle 1. Let's leave angle 3 alone. And then where we see angle 5, we can make a substitution for angle 2, since they are the same measure. And what we have now is that we've decided that angle 1 plus angle 3 plus angle 2 equals 180, and now we've shown that no matter what that triangle looks like, angle 1, 2, and 3, meaning the sum of the interiors, equals 180 degrees, and therefore we prove the triangle sum theorem. Okay? Okay, now let's use that over here to look at an exterior angle. Okay, so a triangle has a whole bunch of exterior angles. Let's take this bottom side and let's just extend it. And then let's label some of these things. Let's label that angle 1, angle 2, angle 3, and angle 4. Okay, so what we can say is, don't we actually know that angle 1 plus angle 2 plus angle 3 equals 180 degrees, and because the triangle sum theorem. But then don't we also know that angle 4 plus angle 3 has to equal 180 because of linear pair? Well, if we know that 1 plus 2 plus 3 equals 180, but then 4 plus 3 equals 180, don't we really know then that 1 and 2 added together has to be the same measure of angle 4? And thus we get the exterior angle theorem. Angle 4 is what we call the exterior angle, and the exterior angle, the measure of it, equals the sum of the other two angles. Okay? And we can do this in a variety of ways, right? I could have extended this side. Boom, 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 boom. And then I get some angle over here, 5. Well, if you use the exterior angle theorem, 1 plus 3 has to then equal 5. And you can do that for as many of the sides as you want. Okay? Because again, the same thing happens. We know that 5 and 2 are supplements. We know that 1, 3, and 2 are supplements. Well, that must mean that 5 does in fact equal the same measures of the sum in 1 and 3. Okay? And again, we can go over this way if we wanted to and get angle 6. We could say that angle 6 has to equal 2 plus 3. Okay, so I've reminded you and proved the triangle sum theorem that says that the three interior angles of any triangle, no matter whether it's acute, obtuse, right, whatever, they all three add up to 180. And then we actually use that to show that the exterior angle to a triangle must equal the sum of the two other interiors. All right, let's just do two problems that involve this stuff. So let's say I have this down here, and I know that this angle is x plus 30, this angle is x plus 10, this angle is y, and this angle is 3x, and I want to solve for x and y. And you're like, oh, check that out. This guy is the exterior angle, and we just decided that the exterior angle has to equal the sum of the other two. So we know then that 3x equals 2x plus 40. Well, then x has to equal 40. And then let's figure out what this is then. So if x is 40, that means that angle is 70 degrees. This angle is 50 degrees, which does lead that to 120 degrees, 3 times 40. And you see that this is 120, and those are 50 and 70. And then what's y? Well, you can actually say that these two are linear pairs. So if that's 120, then y would have to be 60. But we could also use the triangle sum theorem that says that 50 plus 70 plus 60 also equals 180. So again, there's a variety of ways to find x and y. Okay, so this is how in a problem you might actually use the exterior angle theorem and the triangle sum theorem. Okay, now over here, this is a hard one. So I'm gonna go ahead and tell you already that this is a challenge in order to solve it. Now setting it up isn't that bad, because what we have here, we just have two triangles here. I have this triangle here, so if I label that ABC, I have triangle ABC, and so what I'm going to look at is I'm going to look at triangle ABC, and I'm going to look at triangle ABD. Okay, so let's look at triangle ABC first. I know that this angle plus this angle plus this angle equals 180. So then I have x plus x minus 5 plus y plus 15 equals 180 degrees. If I simplify that, that's going to be 2x plus y, and that's going to be a minus 5 and a plus 15. So that's going to be a plus 10. And so then I get 2x plus y equals 170. Okay, so far so good. Now I'm going to look at triangle ABD. So this plus this plus that equals 180 degrees. Okay, so I'm going to take x plus x minus 5 plus y minus 15 plus x minus 20 equals 180. And again, you kind of have four angles up there, but you have this angle x. These two angles form that big angle up there. So I added x minus 5 and y minus 15 angle addition posture that says I can add those together. And then this bottom angle is this. So that's 1, 2, 3 x's, 1 y, and I get a minus 5, minus 15, minus 20 is a minus 40. So I get 3x plus y equals 220. All right, so far I think we're okay. And what I'm going to do here is I'm going to do elimination. And then maybe I'll show you substitution. So all I'm going to do is I'm going to take this value, or excuse me, this, and I'm going to write it right here. 3x plus y equals 220. And if you remember elimination, you typically multiply one of the equations together. You multiply one of the equations by a value, and then you add. So I'm going to multiply the top by -1, and all it does is make all those positives into negatives. And now I'm going to add the equations together. Negative 2x plus 3x is 1x. Negative y plus positive y goes away. Negative 170 plus 220 makes 50. And then once I know x, I can figure out everything else. Okay? Now if you wanted to do substitution, well, you could have took that original equation and said y equals 170 minus 2x. And then substitute it in over here. So we could have 3x plus 170 minus 2x equals 220. Then we could have said 3x and negative 2x is x. We could have subtracted 220 and 170. And, I don't know, no idea. And got x equals 50. Again, once you know x is 50, you can go back anywhere and say, well, if x is 50, this is 100. 100 plus what equals 170, and you can figure out y equals 70. So if you have a challenge problem like that, remember, you might end up with a system of equations. So when we say a system of equations, we mean we have one equation here and one equation here, and we have two variables, and you got to use some of your Algebra 1 skills, either substitution or elimination, to solve for x and y. The majority of the questions will be something like this, where you might have two variables, but you're able to write one equation with just x's, and then you can go back and kind of find y or z or whatever. And again, this whole section is using the triangle sum theorem, which we've used a whole bunch in the class. I proved it for you again, and then I used the triangle sum theorem to show that the exterior angle theorem says that the exterior angle is equal to the sum of the other two interior angles. And then these are kind of the two kind of classic problems you might have to do.